Welcome again, Fraser Nation. We're out here, FraserNation.com, Fraser Nation Entertainment. This is your host, Timothy Fraser, and we are here once again for the Trigonometry Chronicles. We are in a brand new unit, people. This is no longer a drill. We basically went through chapter 5. We've learned 3 standards, and hopefully your Unit 1 test did well. If not, I have my review video for Unit 1. I'll probably throw some more videos to try to get you up the standard, up to par. But for right now, we're going to focus on 6.1, which is angles and radian measure. Okay, so I know throughout your years of mathematics, we've been thinking of angles only in degree measure. So, 1 degree, 2 degree, 90 degrees, 180 degrees. Today, all that changes. Okay, radians, as you can see this word, and where's my young cursor? Right here. Radians right here, that's a whole different way to measure an angle. Okay, and that's principally what we're going to use in this chapter. So 2 things that I need you to have written down, as we know Promethean board rules apply. Students will be able to convert between degree and radian angle measures, and students will be able to find the length of an arc and area of a sector of a circle. So the piece of a circle right here and the pizza slice of a circle. Okay, there's a few things I want you to remember. Number 1, radius is a line segment from the center to the side of a circle. Okay, so real quick, if I draw a circle from center to edge, that is a radius. In this exercise, I use 3.14. You have a pi button on your Android, your iPhone, and on the school calculator. You have a pi button. I recommend you use the pi button, but your answer is not going to be that thrown off if you go ahead and use 3.14. When we go around a circle one time, that's 360 degrees. Okay? I also want you to know that it is also 2 pi. Okay? 360 is 2 pi. Okay? This is radian measure, but we can go ahead and get into that later. And also, one thing I learned in college, I didn't have one of them big, fancy, nice calculators. Never round the decimal until the end of a problem. So if you don't know how to type in a calculator, like expression wise, just write the decimal out and then use that big decimal. Okay, your answer's not going to be thrown off that much. I'm going to write out all 9 decimals in my quest here. So just roll with me. Go along. Next page. So here's a little bit of vocabulary. Number 1, remember I told you, we're using radians, people, okay? This is no longer a drill. Instead of degrees, we're going to measure angles using radians, and it uses pi, okay? So a radian measure could be like 5 pi over 2. It could be 3 pi over 9. It can't say like 275 degrees. Totally different unit. Next vocab, circular arc. So when I say I'm trying to find the arc of a circle, it's a part of a circle, okay? The edge part, okay? So as you see in red, that is your arc, okay? Like arch in St. Louis, arc, people. Central angle, that's the angle that intercepts the circular arc. So it's the angle that sits on top of the vertex, where the vertex sits on top of the center of the circle, and it's the same angle that takes that arc. So the central angle right here, and I know I'm doing a bad job, but that would be your theta right there. Okay, so it's whatever angle you see in the central arc, and let's go ahead and delete that right now. And finally, sector, which I said is a pizza slice. It's the area between the central arc and the central angle in the arc. So here's the edge of the circle. Here's the angle. And when you fill in this area, that's your sector. Okay? Next card. Degree and radian conversions. I'm going to be writing this out a lot. You need to have these memorized. When you're talking about radians and degrees, they're essentially these two right here. This is actually a little confusing, but I want you to pay attention to this right here. Okay. When you need radians, when you need radians, pi needs to be on top of 180. When you need degrees, pi needs to be at the bottom. And the reason that is because right here, when pi is at the bottom, pi cancels out of radian. And then right here, pi is put in. Okay. So when we talk about radians, we're talking about pi. We want pi in the problem. When we're talking about degrees, we don't want pi. We want pi to cancel out. Okay. So in this unit or in this section, we're only concerned about three things: converting between radian and degree mode, and two formulas. Number one, length of an arc. So remember, in a circle, and that was actually a bad idea to do that. Let's do this in black. In a circle, the arc is that piece of the edge. Okay, so here is your arc right here. And you can find how long this would be using this formula. Okay, R is going to be your radius, and central, I don't know why that says arc, people. Don't put that in, people. Don't put that in, people. That's supposed to say central angle. Y'all bad. Central angle. Okay. I also want to say, and let's put this in red, I also want to say needs to be in radians. So sometimes you'll have a degree measure. You need to change that to radians. So it needs to be in radians. Okay. I got to do better on this handwriting, people. Okay. Next, area of a sector. So the area of that little piece of slice. I want you to remember, number one, when we're talking about the entire circle, and notice I have the entire circle filled out in black, the area is pi r squared. This is related to that. When we're only talking about a piece of that circle, it's going to be 1/2 r squared theta. And again, theta is your central angle, and it needs to be in radians. R is your radius. Here's your second formula. I would love it if you memorize these two formulas, but they will be available for you. Okay. As always, we're going to hop into some examples. Yes, you need your examples for full credit in your notes, but yeah, let's go ahead and hop to it. So the book kind of teaches a little bit differently. It'll use fractions. I started just using decimals. Kind of makes my life easier. So right here, we say we want to change each degree measure in the radian. So I need pi in my answer. So I would write this out saying, okay, I got 240. And remember I told you, pi needs to be on top when I'm putting pi inside the problem. Okay? Now I'm going to show you how the book does it. And I'm going to show you how I'm going to do it. So this is book. Okay? So the book is going to make this into a fraction. So it's going to be 240 over 180 times pi. And then it'll simplify this fraction down. So it'll be 24 over 18 pi. And then 6 goes into 24 4 times. And 6 divides into 18 3 times. So this would be 4 pi over 3. Okay. This would be the book answer. And that was terrible. Let's try to circle that a little bit more efficiently. Okay. The way I do it, so let's call this Frenino 2 stacks. Frenino 2 stacks. I just plug this thing into the calculator and get my decimal. Okay. So right here, this would be 4 power over 3 radians. Let's put rads. Over here, the way I did it, I just typed it into the calculator. So I actually typed into the calculator 240, okay, put a parentheses, do pi, and then divide by 180, okay? And remember I said don't round to the end of the problem, but here is the end of the problem. And you approximately have 4.2 radians. If I can get my little A here working. There we go. It'll be 4.2 radians, okay? Now, if you plug this into the calculator, and let's go ahead and do that right quick. You guys can do that too. Let's see. So I would have 4 pi divided by 3. And you essentially get 4.188, which is actually 4.2. So I don't know. Life is a little bit easier for me when I do the decimals because, hey, I'm going to use the calculator's going to use the decimal anyway, but you know, whatever. For example, too, same thing. I could do it the book way, and as you see, you would just make the fraction, separate it down, and I can tell you the book is going to tell you it's going to be 19 over 6 pi. Okay. If you do it my way, you would type in the calculator 570, and then you would do pi over 180. Okay, type it in the calculator like this right here. So 570 parentheses pi divided by 180 parentheses. And when you do that, you're going to get essentially 9.9 radians. Okay. Now, I'm doing this because this is the end of the problem. That's why I have it circled. If we were still in the middle of the problem, I would need 9.943, blah, 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 blah. Okay, but since we're at the end, I'll take 9.9 radians. Okay, and if you plug this in the calculator, you'll see that it's 9.9. Okay, so that's when we're using pi over 180. Okay, over here, we want each radian measured into degrees. So that means that we don't want radians. So we want 180 over pi. Okay. Now, the book way does some counseling, does some kind of handwritten stuff. So it'll be 3 pi over 2. And then in parentheses, we would have 180 over pi. And then, you know, some things would cancel out, like the pi's would cancel, and the 2 would cancel, and you would get a 1, and the 180 would cancel, and you would get 90, and then you multiply straight across, so it'd be 3 times 90, which is 270, and then the only thing you have at the bottom is 1, so you would get 270 degrees. Okay. If you type this into the calculator, if you actually did, you know, parentheses 3 pi over 2, and then type in the calculator parentheses pi over 180, that's not pi over 180. I apologize, my folks. It's not pi over 180, and I have it written down right over here. It would be 180 over pi. If you type this in the calculator like this, then it would also give you 270 degrees. And my pad is not working. Okay. You would also get 270 degrees. Okay. And notice there is no radians in here. We have to cancel radians out. Likewise, this would be negative 1.75. Okay, this is in radians. okay? It doesn't have pi, but this is still radians, so negative 1.75. And then in the calculator, you would do parentheses and then 180 divided by pi. And when you plug all that in, you would get negative 100.3 degrees, okay? Questions? Are you comfortable? Okay. Next card. So, given the length of the central angle, find the length of the intercepted arc of a circle. Okay, so if you go back in your notes, you'll remember that arc, okay, which is S, which is equal to radius times theta. Remember, theta needs to be in radians, okay? So I would say need radians. I don't know why it's so hard to write on this thing today. Oh well. So you need radians, okay? Right here, you have radians already. How do you know? I have this handy dandy pi right here, okay? It doesn't say degrees, so you know you have radians. So I have my formula right here. I have S equals R theta. So what you need to have memorized is S means arc. So I will have S equals, and then you have 15. And how do I know it's 15? Because radius is 15. And then, remember I told you, you can do this in the calculator and just type in 5 pi divided by 6, okay? Have that, like, you know, written in your calculator looking just like this. And when you plug this in the calculator, you're going to get 39.3. Okay. And, you know, this is rounded to the nearest tenth. Now, if you want to just use the decimal, like if you want to figure out what this decimal is, it would be 15. Okay. And then for the decimal, if you plug that in the calculator real quick, so I have 5 pi divided by 6, it would be 2.617938779. Okay. And when you plug this in your calculator, so I have 15, and then hopefully you know that you can use that answer because it's already in your calculator. You still get 39.26, which is 39.3 people. Okay? Right here, that kind of goes along with that same concept. This is in degrees, and I need radians. Okay? So this degrees is not going to work. So the first thing I need to do is radians. Okay? And we know that radians is pi over 180. Okay, so I need to multiply by pi over 180. So this is 77 times pi over 180. Okay. Now, if you can take care of it, it will be 77 pi over 180. Okay. And then you could do S equals 15 for radius, and then 77 pi over 180. You can do that for the calculator, or you can figure out this decimal. Okay, so when we figure out the decimal and we have 77 pi over 180, it's going to be 1.34390352 radians. Okay, I just need enough decimal points here. Okay, and then I would say or 15, and then I will put in here, remember I came round to the end of a problem, so 1.34390352, and when you do that, you would get 20.2. Okay, So if you plug in the calculator like this, or you plug in the calculator like this, you're going to get 20.2. Okay? Next card. All right. Find the area of a sector given its central angle and the radius of a circle. Okay? So I have a circle, I have the angle, I have the arc, and I'm trying to find this piece of the circle, the actual pie slice. So right here, this is in radians, and right here, we need radians. So over here, we would do, in your calculator, 0.5, okay, times R, which is 1.4, okay, square that, or you could do times 1.4. So 1.4 times 1.4. And then this is times, and then in parentheses, 2 pi over 3. Okay? If you type this in your calculator like this, and it would look like this in your calculator, then you would get 2.1. Okay? Because we need to round to the nearest 10. This would be 2.1 units. Okay? If you're doing like I'm going to do and use that big old fat decimal, it's going to be 0.5, okay, and then in parentheses 1.4 squared, and then in parentheses, if we do 2 pi over 3, so 2 pi over 3 is going to be 2.094 395102339, and then type this all in the calculator, and you're still going to get at the end of the day 2.1. Okay, so I'm trying to do it two different ways. It depends on how comfortable you are with your calculator, typing this in or typing this in. Right here, same thing. We could do 0.5, okay, times 6 squared times 54 pi over 180. Okay, and you can simplify that 54 and 180. What's that? I believe that's 9 over 30. So that would be 3 over 10. Okay, you can use 3 over 10. You can use this. Or if you figure out the decimal ahead of time, so let me put an or here, it would be 0.5, and then in parentheses 6 square, and then in parentheses 54 pi over 180, which is how I did it in college, you know. It would be 0.094247776. Okay, and there's some more, but we need enough decimal places. And this is your radians right here. So you plug all this into your calculator, either this way or this way, you're going to get 5.7. Okay. So hopefully I simplified things a little bit. In this section, let's kind of review some things. We need to know how to go from radians to degrees and back and forth. Okay, so we need to know this, and that's rads. We also need to know S equals R theta, and we need this in radians. And we also need to know that area is equal to 1/2 R squared theta. Okay, these are probably the two most important things you need to know. In the calculator, this should be easy for you, and you should be good to go. So, hey, welcome to the good times. These are dynamic times. Have a good one.